Hello, thank you so much for joining. And today we're going to look into another case of function and using stack. And what we are doing is gradually we are um, improving our function, I think we can call it, and by making more, I don't know, official or proper use of the stack. Okay, so in the last video, if you remember, the function example that we look at, there was S3T0T1 that a function used, and we saved all these three register values on the stack. Okay, and then we modified them, and then before we exit the function we actually pull them back, put them back in the original with their original content, right? Okay, so what what we're doing today, what we're learning is, um, you know there is like a handshake between the main program and the function in term of, okay, some functions, sorry, in term of, what did I say? There's a function register. Okay, there's a handshake between the main and function on what registers they each need to save. So they kind of divided up their responsibility. Okay, function said, okay, half of the registers or half of the things I'm gonna take care, you take care of rest of the things, instead of function saving everything. Make sense? For example, so our function is Callee, because it's being called. Okay, so and we are using this notation because later on we will have a function within a function, right? What happens then? You don't have a main, it's a function calling another function. So I think it's better to have this notation, like a main in this example so far we studied is caller because it's calling the function, and function is the function that we are referring to in our example. This guy is Callee. Got it? So here is the responsibility of the Callee, and here is the responsibility of the caller. So Callee, if function modifies any of these registers, save register S0 till S11, then it's responsibility of Callee to temporarily save them, create their backup on stack. If Callee makes a change to return address register, remember that return address is where after function exits it need to go back. So function shouldn't change this, right? But if function for any reason, because it need to say more things, try to update this one, then it's better that it back up this RA so that at the end of execution of the function, it restores it and goes back to that address. Same is the story even as stack pointer. You have seen that we updated it by -12 and when they exit before we went back to the same address we had. So stack pointer, when function exits, it needs to point to the same location before it was called. So if function does anything with this one, it needs to put it back into its original content. And the memory location above the stack pointer. So if you above anywhere here you write, if you have to write, okay, then you have to create a backup, and when you exit you have to put it back into its original content. Okay, you're doing this because the main might have used those things, right? The function doesn't know how many things main use from S0 to S1, but function's responsibility is, or I should say Callee's responsibility is, if anything here it updates, it need to put back into its original content. Now main, okay, when main, oh sorry, I should say caller, when caller calls a function, so before it does that, so caller knows if it has used any of these things like T0 to T6, A0 to A7, or the area of the stack below stack pointer, right? This is the area that function is going to use. These are the registers that where we pass arguments to the function, right? These are our other temporary register. So the caller responsibility is if it's using any of those in the main in its own program, and now it's calling another function, then it needs to create backup of those things that it is using. Understood, right? So I think this handshake is important for a proper functionality. If they don't do their responsibility, they will write over data that and it will create unintentional situation for the program. Okay, so in this previous example that we had, right? Remember this code? We saved S3 T0 T1. Now you tell me. Now in this divided roles and responsibility, who needs to save S3? So we came into the function. So we are modifying S3 T0 T1. Does this function needs to create a backup for S3? Yes. Look, S3 is here. So this is function's job. And a function assumes that, okay, since it's going to use S3, it needs to know that, okay, what if main had used this S3? So it doesn't know about if main has or not, but it needs to assume main has. Okay, so you need to create backup of this one. What about T0? T0 is where? Here. No, that's not function responsibility. Function will use this register without saving this on a stack and backing it up. So function is going to override that. If main was using T0, it should create a backup of that before calling this function. It's not a duty of this one. So what we're doing is we are not creating in the new preserves. Sorry, these are called preserves and these are non-preserved registers from the relative to whose responsibility is what. So function responsibility is preserved. So these are preserved. So function needs to back up them. I think that's how it came with this terminology. So non-preserved is responsibility of main. Just remember that. Okay. So going back, T0, T1, these operations we don't need to do inside the function. Who needs to do? They will move from function to the assembly code for the main program. Make sense? Similarly, so this one we don't need to do in the new example. This one we don't need to do. All right. So then question is, if we don't need to save these two, we only need to save one. So what value we need to have here? We need to store only one word, only this. So this will be -4, yes. Similarly, this will be -4 and then this will be what? 0. So we are storing at that location. Similarly, this will be 0 and this will be we will come back to -4. Okay, rest will be unchanged. I think there is a code for this. So if you look at this, at I we do -4 and since -4 relative to that at 0 location, because now we only need to save this. We're not going down. All right, makes sense, right? And then just S3 and this one. And T0, T1, we're still using them, but we don't have to worry about backing them up. Make sense? Concepts easy? All right, that's it for tonight or today. And we will see each other tomorrow. Take care. Bye.